First, let's open the assembly, include the 2/2 of the loop assembly. Here's the loop with the 2/2, half 1 and half 2. You can see this 2/2 come from the single part, half, and here we don't have any material being signed here. Okay, so you can see the constraint has been made to represent the position constraint. Okay, now we're going to start to create a new simulation. Statics, hit OK. Now you can see we have a global contact. That's contract visualization plot. And to calculation, you can see this 2/2, two surfaces have been bounded to each other, indicating we are not be able to consider this two as two separate parts. Okay, now here we have 2/2 1 and half 2 here, and here is automatically signed as a sheet body. So what we're going to do, we're going to look at this property. Okay, now we would like to change the temperature, input temperature, and then we would like to set our reference temperature at 0 strain at 298 Kelvin, and also use the default setting for the rest. Okay, now we also want to make sure fraction coefficient 0.005, and use automatic, and also make sure check compute free body forces. Make sure you use FE plus, and also use soft spring to stabilize model. Here we are not going to set any fixed, so we are going to use internal relief. Okay, now we would like to use Chapter10 as our folder, as a working folder, so everything will be saved in this directory. Okay, now we're going to first set this as a treat selected body as solids instead of sheet body. Let's save our files. Save all. Now we can set our material. For this one, for the first one, we're going to use type 1060. You can see 1060 alloy is being displayed here, and you can see the thermal expansion coefficient is 2.4 to E minus 5 per K. Hit apply. If we see, you can see the material is assigned to this. Now we're going to assign the material to the bottom half. So plain, okay, plain carbon steel. Okay, you can see 1.3 E minus 0.5 per K. Apply it. Oh, sorry. This one should be applied here. Uh-oh. Sorry, I should close this one first. Let me do this again. 1060. 1060. Apply. Hit OK. And then right click. This time it's going to be plain carbon steel. Apply and close. Now you can see we have aluminum alloy on the top, and then we have plain carbon steel at the bottom. Okay, so let's save this for now. Next, we're going to give the temperature. We already have the bond, the contact at two surfaces here, so we're going to assign the temperature. So temperature. Okay, so we're going to make sure the temperature will be for both. Okay, will be 500 Kelvin. Hit OK. Save the file. Now we have material being assigned to both, and we have connection or contact, and we already set use internal relief. Okay, so we don't need to use a fixture, and we already have the temperature finalized. Now we are going to create the meshes. Create mesh. So for now we just use the default setting. Hit OK. All right. Then let's see if we can run this study. Okay, now you can see the stress is being displayed due to the change of the temperature and the bounded locations. And we can see what we can do here. We can go to here and then explode this part and see what we have here. Okay, we get the stress being displayed on these two constraint or contact area. Let me go to isometric view. Okay, what we can do here, we can edit definition. Okay, so settings, boundary option, we can use meshes. Okay. We can also in definition, we can also uncheck this average result a cross boundary for parts. Let's suppress, uncheck this one, hit OK. See what's happening. Let's look at those values. Okay. Now we can also prop this node, this node, this node, and this node. Okay, so you can see here we have exact value on this node. The stress is the stress are very close to each other. Okay, value, and the stress at the inner surface, inner corner, is a little bit higher, right? So, okay, that's the results. Hit OK. Another thing what we can do here is to create this deformed geometry, right? So what we can do here, click the result, right click it, and then create body from deformed shape. Hit OK. And then you can see the message here, the configuration in this model. We're going to create a new part file instead of the geometry in this file. Here you can see I would like to collapse, okay, and then you can see I would like to give a new name, so it will be loop deformed with my initial, and hit OK. Alright, so it says loop deformed LSX. The part is being created. I would like to open it. Okay, here's the part. You can see there's two imported body is being given here. Let's look at the deformed geometry. Okay, here evaluate. So I'm going to try to find the distance between this surface and this surface to see what's happening. Measure the surface here and the surface here. Okay, it gives me 2.13 inches. So remember this value. Okay, so I'm going to also check the distance on here. So I go to the model, okay, go to the model and then collapse. Go to evaluate, measure this surface and the surface. Oh, I forgot to change it back to the same. Okay, you can see This is 22.05 inches, and the other one is a little bit longer than oops. Okay. A little bit longer than this one, so it is deformed. Alright, so go to isometric view to bring it to the normal section. Okay, here is the end of the chapter 10.